Hello, welcome to video number 9 in our series on option pricing and trading strategy analysis. To this point, we've been looking at the relationship between profit from a position in a long or short call or put as a function of stock price at option expiration. Okay, and again, at that point in time, the only type of value that remains in the option is intrinsic value. You'll remember that the second component of option value is time value. And time value is a driving force in option value prior to option expiration. And now we want to begin addressing equilibrium option values prior to OE. And so we're going to have to introduce more factors that impact the market price of a call or a put. So again, we've seen profit diagrams that look like this. For example, that would be the profit diagram for a long call, 2 straight line segments, and we see a bend at the strike price. Because we see a bend, we know we must be looking at option expiration at that moment in time during the option's life. And we know that there are 2 linear segments, 0 slope, and if I just have one contract depicted here, slope there plus 100. Right here will be a profit diagram for a short call. So this is long call. This is short call. Up here I'll put long put. There's the strike price. So a long put looks like this. And then over here I'll put a short put. Okay, and so those are the 4 profit diagrams that we've seen to this point. And they all have bends. They all have 2 linear segments with slopes of 0 and the absolute value of 100, right? Well, when we just have stock price here on the horizontal axis at a point in the option's life that differs from option expiration, we don't see straight line segments, okay? Let's now focus on the long call. I'll erase the other profit diagrams. And with a long call, if I'm looking at this at a point in the option's life other than option expiration, then I have to specify what that time is. And we're going to look at an option pricing model in great detail soon. But let's just say this is depicting an option with 1 month life remaining. So, as a boundary, I'll put in the profit diagram for a long call. Okay, it's a boundary for us. And we know this is as of option expiration. So notice I don't indicate anything here because I'm going to have multiple graphs appearing on this same 2 space. Multiple values for the profit for this long call position associated with different stock prices. That's what this shows. But this shows as a single moment in time during the option's life. Here's another curve, and notice this curve is convex. Okay, there's another curve. And notice it's curvilinear. There are no straight line segments on it. And this is the shape, this convex shape is the shape of a profit diagram for a call option prior to option expiration. At any point in the option's life, it will have that general shape. And then I'll put another curve up here. This one will be in blue, and like that. And that is another profit diagram for an investment in a call. Make sure this blue has a segment beneath the horizontal axis. Okay, and this segment, which I'm trying to draw as also being convex. There we go. Okay, this shows a profit diagram for a long call position for another different time remaining. And we're going to choose a point. We're going to choose a point on the stock price axis and think about this profit concept in some detail. However, we can make it easier. We know that profit is equal to the value minus cost. The profit at a certain point in time, I'll call little t, is equal to the value of the position at time t minus the cost. This is for a long call. And so, because cost is a constant, we just use it to move this general shape around. So now I'm going to switch the analysis to one where we have a value diagram to make the points that are made, and then we'll go switch back to the profit diagram. So this will be a value diagram for a call option. If that's the strike price, one of the relevant value diagrams looks like this. So here we have call value as a function of stock price. And we're going to have several lines which will all be unique to a given time until expiration assumption. So there is the where the time to expiration is 0, we're at it. And here is where the time to expiration is some other value, maybe 1 month. And then I'll put another one in red also. Okay. And so to understand this, we're going to choose this stock price right there. And we're going to consider what will be the value of these options, each with different amounts of life remaining. And we're going to do that fixed at this price here. Say that price is 31, okay? X might be 30. And so we'll draw a dashed line vertically, a dotted line rather, and we're going to get 3 values, okay? And according to my drawing, which is based on some imagined pricing model for options, we note that, when time to, like for this curve, time to expiration is 0. For this curve, time to expiration equals 1/12 of a year. Maybe for this, time to expiration equals 2/12, 2 months of a year, okay? And we note, wow, as the life of the option gets longer, all else equal, ceteris paribus, all else equal, the value of the option is higher. It's common sense. If an asset has identical characteristics with another asset, except for one in that the remaining life differs, then it just makes sense that the one with the longer life would be more valuable. There's a bigger chance for the stock price to move a lot, so your option could increase in value. And that's what this makes clear. that the longer the life of an option, the more valuable the option is, ceteris paribus. And here we can see it in the value diagram. And I can transform this into a profit diagram, and I'll do that up here. There's a profit diagram, profit as a function of stock price, and then we just have these down here. Same thing, okay? Every curve up here at each stock price value is just the value here, less the cost of the call, as we've seen before. Okay, so that's very important to understand how that works. Well, you might be wondering, it appears then that the value of this call option depends upon the stock price, the exercise price of the option, and now time until expiration. Are there other factors that impact option value? And the answer is yes. This begs the question, does there exist an equation that can help us estimate a fair price for an option pricing model at any point in time? And yes, there are equations that exist, models that exist, and we'll be studying one of those in some detail in a bit. So at first, I'd like to make note that the value of an option, both a call and a put, so I'll put an O, indicating both calls and puts. The value of the option, this is the market price indication, O, is a function of, I'll put 5 factors. Stock price, S. Exercise price, X. T is remaining life, measured in years. The remainder of the option's life measured in years. So a value for T of 1 means 1 year. A value for T of 0.5 means 6 months, etc. There are 2 more factors. One is R, and R stands for the risk-free rate of interest. And the model that we're going to be using once this risk-free rate of interest measured in continuously compounded return form. And that would be the natural log of the price relative, not a standard holding period return form. The 5th factor we'll talk about, I'll refer to as EV, okay, EV. Many textbooks use a sigma, but I like EV better. No, it's not electric vehicle, as wonderful as they are, but rather expected volatility. Expected volatility. And what does that mean, expected volatility? Well, it's the expected volatility, the expected variability of the underlying asset's price, in this case, of the stock's price for a specified period of time. And that period of time is from right now, the moment that we're contemplating or trying to figure out what the option price would be in equilibrium, and the expiration of the option. So this expected volatility here is relating to the expectation for the variability in the underlying stock's price between now and the option expiration date. Okay, so it's very specific. And that's our little function indicating that this value depends upon those. And remember, the O means both call and put. Okay, value depends upon those things. Now, we've already seen intrinsic value. For a call option, call intrinsic value is the maximum of stock price minus strike price, or 0 times 100. I'm multiplying by 100 if you want the value of the contract. If you just want the per share equivalent, you don't multiply by 100. And put option intrinsic value is the maximum of X minus S, or 0 times 100. Okay, so we've already seen how S and X work. One important thing to keep in mind is X, as I've mentioned earlier, is an attribute or a characteristic of the option. Okay, and It is what it is and won't change. The strike price of an option will not change. I have to have a little asterisk here and say, well, assuming there are no stock splits or stock dividends, we'll talk about that later, but in the absence of stock splits and stock dividends, the strike price is a fixed known commodity. But stock price changes, time to expiration is constantly changing as time ticks away. The market risk-free rate of interest is changing, and expected volatility assumptions may very well be changing. And so we've seen that at option expiration, these are the only two things that matter. But the value of an option prior to expiration depends upon how much time is remaining, what's the opportunity rate of return at the risk-free level, the risk-free rate with an appropriate maturity, which just means a maturity to match the life of the option, the remaining life of the option, and then expected volatility. So we're going to now look at an option pricing model that considers how this might look, and we'll do that in our next video.